Ever looked up at the night sky and seen that faint red dot? That's Mars. But what if I told you that billions of years ago, Mars wasn't red, but blue? A vibrant, water-filled world, strikingly similar to our own Earth. A lost planetary twin. Let's journey back in time to uncover the story of a planet that had it all, and then lost it. Imagine a young Mars nestled comfortably within the sun's Goldilocks zone. Not too hot, not too cold, but just right for liquid water to flow. Pictures from our rovers show us undeniable proof. Ancient riverbeds carved into the landscape, vast deltas where water once pooled, and evidence of a massive ocean that may have covered most of its northern hemisphere. This wasn't the desolate desert we see today. This was a world teeming with potential, a second Eden in our own solar system, a place where life might have taken its first breath. So, what happened? Where did all the water go? This is the story of the great Martian dying. The prime suspect is the loss of its protective magnetic field. Unlike Earth, whose molten core generates a powerful shield against the harsh solar wind, Mars's core cooled and solidified. Without this shield, the sun's charged particles relentlessly stripped away Mars's atmosphere, thinning it out over millions of years. As the atmospheric pressure dropped, the water on the surface either evaporated into space or froze solid, locking away into the polar ice caps and beneath the dusty red soil. The blue planet turned red. The vibrant world became a frozen, barren desert. But the story isn't over. Our robotic explorers, like the Curiosity and Perseverance rovers, are unearthing its secrets right now. They're like robotic geologists, drilling into ancient lake beds and analyzing rocks for clues. And they've found something incredible: complex organic molecules, the very building blocks of life as we know it. This isn't proof of life itself, but it's a tantalizing hint. We're now searching for biosignatures, fossilized microbial mats or other chemical traces left behind by ancient organisms. Finding just one fossilized microbe on Mars would be one of the most profound discoveries in human history. It would mean we are not alone. Could we bring Mars back to life? The idea is called terraforming, essentially planetary engineering on a colossal scale. Scientists have proposed wild ideas, from melting the polar ice caps with giant mirrors to release CO2 and thicken the atmosphere, to introducing hardy Earth microbes to kickstart a new ecosystem. But the challenges are immense. The timescales are in the thousands of years, and the ethical questions are staggering. Do we have the right to remake an entire world in our own image? And shouldn't we focus on protecting the one blue planet we already have? Mars serves as a cosmic mirror, a ghostly reflection of a potential future for Earth. Its story is a chilling, cautionary tale written across an entire planet. It shows us how fragile a world's climate can be and how quickly a paradise can be lost. When we study Mars, we're not just looking at another planet. We're learning profound lessons about our own. It reminds us of our responsibility to be stewards of Earth, this beautiful blue marble. The quest to understand Mars is ultimately a quest to understand ourselves and our place in the vast, silent cosmos. Thank you so much for joining me on this journey to the Red Planet. If you found this as fascinating as I do, don't forget to like, subscribe, and hit that notification bell for more cosmic adventures. See you in the next one, and as always, keep looking up.